This week, you will start to work with data in R. We will load or import external data from a CSV file into a data frame. We'll learn what a data frame is and how to look at the structure of a data frame. We'll also learn how to subset specific portions of data frames and understand how R deals with dates. We'll be working with the portal small mammal data, and we'll be working with animal species diversity and weights found within sampling plots. The dataset is stored as a comma-separated value, a CSV file, where each row is an observation for a single animal, and the columns represent different variables that we'll look at in a minute. So I have my RStudio open. The first thing we want to do is create a new project, new directory, new project, and I'm going to name this starting with data. For some reason my R session crashed, but it looks like it restarted automatically, and now I have this .rproj file, and now I need my R script. And I'm gonna go ahead and save this, and I usually call my script the same thing as my project, and you can distinguish them with the extension. This .r is my script and the .rproj is my project. We'll be importing data from a URL, and I want a folder to store that data. I'm going to call this data_raw. Remember, it's good practice to keep raw data separate from the cleaned data or the data that you've worked with. So to import our data, we're going to use the download file, and I might start this code off by saying download and load data into R. To download a file from a URL, we can use the download.file function. And I am going to copy and paste the code from our Canvas file to reduce typing errors. Notice when you put your cursor over the function name, this yellow box comes up showing you the arguments that that function expects. So this download.file function expects the first argument to be the URL. So here we've supplied the the URL address, and the second argument is something called dest file or destination file. So this is the location on your computer where that file will be saved. So this is the destination of the file you want to download. And in this case, I want to save it in our data raw folder as this particular name, .csv. So if I navigate to my data raw folder, I haven't run the script. Let's do that now. And you see that it does require an internet connection. And I see that this Pac-Man symbol, which tells you that R has completed the command and is waiting for another one. So it's ready for another one, and we can see that that data downloaded into the folder. We're ready to load the data into R. So we've downloaded the data onto our computer. Now we need to get that data into R. To do this, we want to save the data inside of an object. Let's call it surveys, and we'll assign values from the file using the read.csv function, and we'll tell R read the CSV that's in this data raw folder that's called portal data join.csv. I'm going to run that, and now our survey appears in our environment. The first thing you want to do when you load a new data set into R is to look at its structure. We can do that using a few functions like head, which produces the first 6 rows in our data frame. And this helps you give a good idea of what the columns are and what are the typical values for each column. We can also view the data frame that we created using the view function. So I could run it in line here, or I could click on the surveys object in my environment pane, and it would run the view surveys. So what we're looking at is our surveys data frames. Data frames are the most standard type of data structure for tabular data or spreadsheets. And this is what we'll use for statistics and plotting when working with Neon data. You can create a data frame by hand in R, but it's more common to load a CSV file using this function, this read.csv function, and importing it, creating the data frame that way. So our data frame represents the data in the tabular format where the columns are vectors that all have the same length. And because columns are vectors, each column must contain the same type of data, whether that's characters, integers, or factors. And here each row is a single observation. Remember, those are those tidy rules that we learned about a few weeks ago. There are a few functions that you'll want to use to inspect your data frame after importing it. And these will help you understand the structure of your data. To look at the size of your data, you can use dim function for dimensions. This will give you the number of rows and the number of columns. If you want to be more explicit, say you're only interested in the number of rows, the nRow function is useful. And the nCol function is useful if you're interested in the columns. We've seen head to look at the first 6 lines, the first 6 rows of our data frame. And we can use tail to look at the last 6 rows. And this is useful to make sure that the values are what you expect them to be. We can look at the column names using the names function. I frequently use this function when I forget the name of a specific column, or I forget the syntax, whether there's an underscore or not. And you can also look at names of columns with row names. But for what we'll be doing, we probably won't be working with row names. It's good for you to know these different functions. In addition to the structure function that we saw, if we scroll up to the top, what's useful about this structure function is that it gives you the class of the object. In this case, it's a data frame with 34,786 observations or rows and 13 variables or columns. And you can see the different columns and the type of vector that each of these are. So this is an integer vector. Another useful function for summarizing is the summary function. I'll scroll up a little bit, and what's useful about this is that it gives you a summary of each individual column. For example, hind foot length, the minimum value is 2, the maximum value is 70, and it looks like there are 3,348 rows where there's no value, so NA. Another important concept about working with data frames is how to index and subset data frames. Indexing and subsetting are useful for when you want to select particular pieces of data frames. So let's say you have 13 columns and you're only interested in 2 or 3 of those columns. Let's see an example of how you would subset the first element in the first column of the data frame. The subsetting notation follows the syntax where you specify the data frame you're interested in. In this case, it's surveys, and we use the square brackets to indicate that we're interested in subsetting. There's a few kinds of things that can go inside of the square bracket. The most common is this row, comma, column notation, where the first position you indicate the row number that you're interested in, and in the second position after the comma, you indicate the column that you're interested in. In this example, we're interested in the first row of the first element. So I'm going to run that, and it returns a value of 1. If we go back to our data frame, we can see that the first row in the first column is a value of 1. Let's try the first element in the 6th column. To do this, it would have a similar format. We're calling the object or the data frame, square brackets. We want the first row in the 6th column. When I was first learning R, I could not remember which of these came first. Was it the row? Was it the column? I would always have to look it up. So I finally came up with an acronym called RC COLA. If you know what that is, it might not exist where you grew up, but where I grew up, it was this generic type of soda, is like Coca-Cola, but it helped me remember RC COLA, RC for row, comma, column. So I hope if that doesn't work for you, hopefully you can come up with a more creative acronym to help you remember the order. And let's go ahead and run that line. The result is NL. Let's go back to our data frame. Surveys, the first row, and the 6th column. 1, 2, 3, 4, 5, 6 column. Column 6, species ID. Let's start to get a little more complicated. What if we want the first column of the data frame, but we wanted all rows? So R understands that if we don't provide a value in this position for the row, then it will return all values. So we're asking return all values for the first column. And if I run this, it'll produce, all of the, I guess there's a limit on printing out, so probably 1,000 entries. Well, what if we wanted another way to select the first column is to provide a single value inside the square brackets. When there's no comma inside the square brackets, R understands that as a column position. So this line of code where we have a single value of 1 inside the square brackets is equivalent to the above line where we're providing no value for rows, comma, a value of 1 for the column. So when there's no comma, R understands that this is the position of the column you're interested in. So if I ran that, it would be equivalent. Let's start to get a little more complicated. Let's say we're interested in the first 3 elements in the 7th column. We start with our survey's data frame, square brackets, but now we want, for rows, we want rows 1, 2, and 3, and we want the 7th column, so I'll put that there. Now to tell R that we want this series of rows, we can use this colon notation. So we start from row 1, colon 3, and that R understands that as this sequence of positions. So the return will be the rows 1, rows 2, rows 3, and from the 7th column. When I run this code, we see the output are these 3 rows, row 1, row 2, row 3, for the 7th column. In these above examples, we've been working a lot with columns, but let's say we're interested in the 3rd row of the data frame. I'll start with the object, square bracket. Repetition is good for really remembering those different notations. So I want the 3rd row and all of the columns. So I'm going to enter a value of 3 for the 3rd row, and like we did above where we left the row position blank, if I leave this column position blank, R understands that as returning all of the values. So I want row 3 for all of the columns. And when I run that, you can see this is row 3 and all of the columns are listed there. Let's see a few more examples. How about the first 6 rows of the data frame? If this sounds familiar, it's because there was that built-in function that we saw. Up here, we used head surveys, which returns all columns for the first 6 rows. But if we wanted to do it using this notation, the square bracket notation, we would use the colon syntax where we're giving our sequence from 1 to 6, and we'll leave all of the columns, we'll leave the column position blank. And let's go ahead and store this into an object called head surveys so that we can see the object created. So we saw the head function. We saw the square bracket notation where we're designated rows and columns. And all of these examples, we were telling R that we wanted specific elements. But we can also use this notation to tell R to exclude certain elements. Let's tell R to return the data frame except the first column. This would follow the similar square bracket notation following the object name, and we could use the row comma column format. And in this case, we want all columns except the first, and to do that we would use the minus sign followed by the column that we don't want. So everything except the first column. And if I scroll up, then we would see that the first column, maybe one more, the first column begins with month in the return output, whereas in our original data frame. The first column is record ID. And let's say we wanted to reproduce we want everything except the row 7 through the last row. This would be equivalent to telling R that we wanted only rows 1 to 6. We can also tell R that we want everything except row 7 and onward. To do that, we would use this row, comma, column format, and in the rows, in order to say except particular rows, we have to use the minus sign in front of these parentheses, and inside the parentheses would be the sequence of row numbers that we wanted to exclude. If we're telling R to include a sequence of rows, we don't need the parentheses. But when we're using this minus symbol, we need to tell R that these are the rows. We need to use these parentheses. So we saw 3 ways to achieve the same result. In this example, we're telling R to exclude certain elements. In this example, we're telling R to include certain elements, which is the same as our head surveys. So our head surveys is actually selecting rows 1 to 6 and all columns. In these examples, we've been using the row number or column number, but you can subset your data frame by calling indices directly. For example, I can use this square bracket notation to call the species ID column, and it'll give me all values for that column. Remember, when there's no comma inside of the square bracket, R understands that as a particular column. But that would be equivalent to specifying all rows and this same column. And the most common way that you will subset your data frame is with this $sign notation. So the $sign after your data frame name designates a column. So if you want to isolate a specific column, you would use a $sign. So surveys, $sign, and then this menu will pop up where you can use the arrow keys to navigate to the column name that you want and use the tab autocomplete. So all of these 3 lines produce the same output. The final thing we'll work with today is formatting dates. Remember that dates are especially problematic in programs like Excel, and they're equally challenging to work with in R. One of the most common issues when you're first learning R is having to convert date and time data into something that R understands as a date. Because sometimes you want to use date as a continuous variable. Time is continuous, but sometimes you want R to understand your date or time as a factor, a category. Let's look at the structure of our surveys data frame using the str function. And let's scroll up to the month, day, year. So it's best practice to keep dates in separate columns specifying the year, month, and day. It's one of the tidy rules that we learned. And R understands these as any integer vector, just like record ID or hindfoot length or weight. So it will treat these variables, these columns, the same way it treats hindfoot length. And for some things that might be fine, but a lot of the times we need to tell R that these columns are dates, because dates aren't like regular numbers, right? We have a 365 day calendar and the dates are cyclical, right? To tell R that these columns are dates, we'll be using the year, month, date function from a particular package called lubridate. If you've never installed lubridate before, you will need to use the install.package, nothing came up, install.packages, this plural, with the name of the package or library that you want to install, because this is actually the third time I've recorded this video. I've already installed it, so I don't want to reinstall it. The first take, my dog wouldn't stop barking. The second take, my microphone messed up, so I'm crossing my fingers. This is the third and hopefully final take, because it's the end of the day here and I'm ready to upload this video. So go ahead and install lubridate, and when you're ready, when you've installed it, we'll have to load that library. You only have to install it once, and then you can call that library into your R session using the library package call. So I'm going to run this. And now we can use the year, month, date function, which is inside of this library. Let's start by creating a date object called myDate. And we'll use the year, month, date function, ymd, and it expects a vector. So in this case, we'll give it a character vector to indicate year, month, and date. And I'll run this code, and then I want to look at the structure. Actually, let me write this up here. Structure myDate. And we can see that R now understands this character vector as a date class. Let's play around with this year, month, date function a little bit more. I'm going to copy and paste this, and instead of providing it a character vector, I want to nest inside of this function another function called paste, which pastes together all of the values you provide it with a separator that you specify. So in this case, let's use 2015, the value of 1 and the value of 1, so 3 values, and we need to, one of the required arguments is a separator. In this case, we want a dash to mirror the format above. So let's just run this line, this nested paste function, to understand what it does. So it pastes the values in parentheses with separated by the separator that you specified. So in this case, notice how it's a little bit different. There's no 0 for the month or date. And let's go ahead and rerun this year, month, date function. with this paste function nested inside. And now let's look at the structure of my date again. I'm copying, pasting. Now we can see that R understands that this is a class date, and it automatically formats it in this standard way with that 0. Let's do this with our year, month, day columns for our surveys. What happens if we paste the surveys, comma for column, year, surveys, comma, month, and surveys, comma, day. And the separator, we want the same. Let's see what happens when we run this line. We see that, I was noticing there's this weird number, and it's because I must have scrolled down too far. So we want month here. And I'll rerun this, and now I see that a similar format where we've got year, month, and day. So let's create a new column in our surveys object. To do that, we specify our data frame, use this $sign notation, and this is a new column, so it's not going to appear here. We want to give it whatever name we want. In this case, we want to give it the date name, and inside of that, we want to use the year, month, date, and we're going to nest this paste function inside of that. And I'm going to run this command, and I receive this warning message, 129 failed to parse. So let's go ahead and look at the structure of surveys. And we see this new column at the end. It recognizes that as a date. The format looks okay. I'm going to go up to my data frame and view it. And it looks to be okay. I'm going to look at the bottom. Everything looks... So I'm trying to figure out what went wrong. So another handy function that we learned about is this summary for surveys. And that'll give me a summary of all of the rows, including the date. So I can see that the oldest date is this July 16, 1977, and the youngest date, this most recent date is December 31st, 2002, and I also see that there are 129 rows with maybe no information. Well, let's figure out what's going on in these 129 rows by telling R to subset the 129 rows where there's an NA value for this new date column that we created. Let's store this inside a new object called missing dates, and we'll assign values from this function, from this subsetting that we'll do. So remember, our subset, we specify the data frame followed by the square brackets, and in that square brackets we want specific rows from specific columns. In this case, I want all the rows where date is NA for columns year, month, day. That sounds a lot complicated, but let's break it down. So to call multiple columns, remember we could specify their number, but we could also call them by name. To call multiple columns, we need this C function to combine. And if you want, you can question mark C. And we can see that it's a generic function which combines values into a vector. And in this case, we want the columns year, comma, month, comma, day. All right, so I'm specifying my columns, and now I need to specify my rows. Well, I know that I want rows from surveys.date that are NA, and to do that, there's a useful function called is.na. This returns all values inside the parentheses that are NA, and those will be the rows that are NA inside this column. So if I ran this part by itself, is.na, close parentheses, what it's evaluating at each row position, whether that value is true or false. So is row 1 of column date NA? No, return a false. That's not very useful for us, but when we use it inside this subset, R understands where to return values that are true. And I'm trying to scroll to see any trues, but I don't. So let's go ahead and run this last line of code. And now we see this missing dates object data frame in our environment. When I select it, it runs the view function. And now we can see, okay, so I'm seeing there's 2 dates that seem to be problematic. September 31st, 2000 and April 31st, 2000. And if you remember your calendar, this date doesn't exist, right? There is no date of September 31st. So R doesn't know what to do with this, and interprets these dates as NA, returns a value of NA because these dates aren't real dates, they don't exist. So to correct this, if it were me, I would go back to the original data sheets, if that were possible. If not, I might look at the unique observation dates to try to identify, was there a September 30th and not an August 31st? I mean, it's hard to tell whether the mistake is in the month or the day. So I might try it that way or go back to the original data sheet. So it's difficult to correct this kind of error. In this session, we saw how to import data into R using the read.csv file. You'll use that with your Neon data. We saw a new function, so this is new vocabulary for the new language that you're learning. We learned all about how to subset using the RC notation. And we saw how to call specific columns, especially using the $ notation, which you will use repeatedly. And we learned how R understands dates and how to format date columns in R. As you're working through this week and next week, think about how these concepts apply to things you want to do with your Neon data. Right? You might be interested in looking at changes over time, so you'll be working with those date columns. You might be interested in specific species, so you might use the $ notation to specify the species ID, or the subsetting notation to pull out the specific data that you're interested in a similar way that we use the filter functions in Excel. But now we have a way that we can do this in a more automated and reproducible way.